all of you. Today I discuss the image transform, the basics of the image transforms. First of all, discuss the what is the image. Image is the two-dimensional signal, and transform is just transform means you have a transform. Need of the transform is for the easy for the computations, and the role of transform is just an example, the giving the white light through the prism and transform in the 7 colors. This is the basic example of the transformations. Let's quick review of the basic transformation theory. Here the pictorial representations of the transforming. Here any signal in the time domain is transformed in the frequency domain. This is the reversible process. You have transform in the forward transform and then get back to the original image by taking the inverse transformations. This is the basic theory of the transformations. And let's the basics of the transformation is the key parameter, key function is the basis function. It is also called as the kernel. The basis function is the finality of the coefficient and orthogonality. These are the basic key factors. And the basis function can be mathematically represented as x equal to summation I is equal to 0 ci phi I. Here the x capital A is the input signal and ci is the transform coefficients and phi I is the basis function. This is the mathematical representation of the basis function. And then the transform can be represented by the various classes according to the basis function. Here just basic idea about the transformations. The basic transform, you have also know the Fourier transform. Fourier transform is discovered by J.S. Fourier. This is J.S. Fourier is a French mathematician, mathematical physicist. Gives idea in 1809 and it is used in the flow of heat through the objects. And this is the mathematical representation of one-dimensional discrete Fourier transform. Here the simple here giving the xn is the input signal and then taking the one-dimensional Fourier transform, and this can be represented xk and taking inverse of this transform taking the original signal. And this is the mathematical representation of one-dimensional discrete Fourier transform. Here xk is equal to summation n is equal to 0 n minus 1 xn e to the power j 2 pi kn. Here xn is the input signal, xk is the representation of the signals. And then this can be represented by two-dimensional discrete Fourier transform. Then xn can be represented by two-dimensional way fmn, and xk can be represented by fkl. This is a two-dimensional representation, and this is the basics of the two-dimensional Fourier transform representation. This is the mathematical representation of the two-dimensional discrete Fourier transform. Here xk is the one-dimensional Fourier transform and this is the two-dimensional Fourier transform representation. This is the mathematical representation, and here this is the example of a two-dimensional Fourier transform can represented by taking an image as a signal and taking a forward transform and compute the magnitude and phase characteristics of this image, and then you have compute the importance of the Fourier transform to calculate the phase characteristics of a given image, like image 1, image A and image B, and taking the Fourier transform of image A and find out the magnitude and phase characteristics of this image and taking inverse of this Fourier transform and to get back a reconstructed image A. And the similar process is taking in the read image B and taking the Fourier transform of this image and calculate the magnitude and phase characteristics, and then taking the reverse of this reverse Fourier transform of this image and reconstruct the image B. Here this is the taking the cross connection and magnitude of image A and combined with the phase of A image to the magnitude of B, and then importance of phase in this pictorial image. Here taking the original image is taken as a cameraman image, and the second image denoted as the Lena image, it is denoted as B, and after the phase reversal of cameraman image, here this is the some image features of the Lena image is given obtained in this after reversal, phase reversal of the image A, and in the second image you have Lena image after phase reversal. Here the cameraman features are dominant feature. This is the importance of the phase in this image processing. Here another application of Fourier transform in the image processing, the most important applications is image filtering. Here taking the input image FMN and the transform function is HMN, and this is the GMN. FN is the input image, FM is the input response of the filter, and GMN is the output image.